All right, everybody, welcome to the video here for lesson number 1 in Unit 9 on the types of distributions that we have in statistics. So one of the things that we have to be able to do from this first lesson is to be able to input data into our calculators to determine the mean and the standard deviation of a sample. So number 4 is the last question of the lesson that we didn't get a chance to get to yesterday. So it says a salesman kept track of the gas mileage of his car over a 25-week span. The mileages per gallon rounded to the nearest whole number were, and it gives you all of the data for the entire 25-week span. So since this is the entire population of data, it's not just a sample of a bigger piece of data, all right, we can find the mean and the standard deviation right in our calculators. So first thing we have to do is we have to put all of these datas into list one. So let's take a look at our calculator here for a minute. So we have to put all the data in. So the first thing I have to do before I do that is clear whatever list I had in there before. So if I go to stat and I go to option 4 and then hit second and the number 1, I can actually clear the list. I already knew I had data in there, so I'm clearing it right away. Then if we go back into stat and edit, I then can input all the data from this problem. So this just might take me a second here. So if we input all the data, so I have 23, 27, 27. Even though 27 is there twice, you still put it in twice, so it counts twice. And as we're putting all of this in, just be careful, especially when the numbers are close to each other like this, because you don't want to miss one. And I put way too many pieces of data in. Let's see where I made a mistake. So if we go back here, let's just look for my mistakes. So this is good for us to see. So start from the beginning. So I have 23, I got 27 twice, 28, 25, 26, 25, 29, 26, 27. We're good so far. 24, 26. I missed a 26. Then after 26 should have been 24, which it is. Then after 24 should have been 27. Then after 27 should have been 25. Then 28, then 25. Then 26, then 25. 29, 26, 27, 24, and then 26. So after that, I had extra data. Okay, so we checked it, we have 25, and we double checked it, so we're good. So now that we have all the data in there, I can go back into stat, so hit second, and then mode to quit back to the main screen. Go to stat and edit. Not edit, sorry. Go to stat and calculate one of our stats. Now, new calculator people, this is what you're going to see. All you have to do is go down to calculate and hit enter. All of your data is going to pop up. If you're an old calculator person, what you're going to see on your calculator looks like this. And then you want to put L1 right after it. And then hit enter. You get the same data. So here's our data, and there's a couple pieces of information we need. So we need this mean, which is 26.04, so we could put that in our problem. So we could say x bar is 26.04. And then let's think about this again. So we have this whole bunch of data for this car, but it's a sample of all of the data of gas mileage for this car for the life of the car. So we're going to be able to find a sample standard deviation. 9 times out of 10, you're going to use the sample standard deviation, which in this case is 1.54. Then it says a relative frequency histogram was constructed for this data. Describe the shape of the mileage. This shape looks relatively normal. It looks like about half the data is above and about half the data is below the mean. It then says draw a smooth curve to model the distribution. So we could draw a smooth curve. It should look like a bell, and we'll talk a lot more about bell curves in lesson 2. It then says state an interval that represents the mileage that fall within 2 standard deviations of the mean. So if we take 26.04 and plus 2 times 1.54, that's going to give us the top value for the 2 standard deviations above the mean. Which gives us 29.12. So right around here. And if I do the same thing but subtract the 2 standard deviations, and what we learned at the beginning of this lesson was that 2 standard deviations within the mean is going to be a lot of your data. 3 standard deviations is going to be basically all of your data. So if you look, that's almost the whole amount of data. The next question is the interesting part here, and this is what we're going to start to kind of get to as we get further into this unit. It says, months later, the salesman told his boss that the mileage for that week was 27 miles. Is this unusual? And the answer is no, right? If we look at 27, it's kind of close to the mean. It's within about 1 standard deviation of the mean, so that's relatively normal. If we had an answer of like 35 miles, that's way over here. That's not even on our chart. So that would be highly unusual. All right, so we'll start to figure out how we could actually calculate usual versus unusual. But for right now, anything that's kind of close or within a standard deviation of the mean, we can say is kind of a common value. Let's move on to the homework. So in the homework, we have this question about air conditioners and how much people use it, or how many years it's in their homes, stuff like that. So here's your data. So the first question says to describe the shape of the distribution of the air conditioner and explain your answer. So again, even though the peaks in the middle are not here, it does look somewhat normal, right? It's not skewed in any way. It's not like we have really tall bars over on this side or on this side, right? So we have a normal curve. Relatively normal curve. It then says, is the mean distributing closer to 15, 20, or 25? So here's 15, here's 20, and here's 25. The mean looks closest to 20. The mean is going to be where we are about half of the data above, half of the data below. Then it says the standard deviation of the age is 3, 6, or 9. Remember, standard deviation is how far the data is spread out. So if we wanted to figure out the standard deviation here, remember 3 standard deviations above and below the mean should represent our entire histogram. So if I was to take 3, 20 plus 3 is 23, plus 3 again is 26, plus 3 again is 29. If I was to take 20 and subtract 3, I'm at 17, 14, and then 11. That represents the top and bottom of my curve. So 3 is going to be my standard deviation. And we can say because 20 plus 3 times 3 is 29, which looks like it's about the top, and 20 plus 3, or not plus, minus 3 times 3 is going to be about the bottom. So then we can see that in our curve. If I was to use 6, the top would be like way over here, and the bottom would be like way over here. Same thing with 9, it would be too spread out, right? This represents our data. It then says, mark 1 standard deviation above and below the mean on our graph. So if we're at 3 of a standard deviation, I want to go up to 23, and I want to go down to 17. Notice that represents a good portion of our curve. The next question gives us another histogram. This one is automobile accidents per year. It says, describe the shape, center, and spread of the data. So it seems like this is, again, a normal curve. All right, so we'll say this is normally distributed. If I had to take an estimated guess, I'd say 90 is the mean. If you chose something different like 91 or 92, it's not wrong. Then we have to figure out, well, I need to figure out how much do I spread above and below the mean. So if I take 113, which looks like to be the top number, and subtract 90, which I'm estimating as the mean, I have about 23 pieces of data above. If I do the same thing with the bottom number, 90 minus 65, I get 25. Now I want to spread the data so that 3 standard deviations above kind of get to that top number. So if I take 23 and divide it by 3, I get about 7.6. If I take 25 and divide it by 3, I get about 8. So what I'm going to assume is the standard deviation is 8. And again, it's an estimate. If you put 9, it's not wrong. If you put 7, it's a little small, but not wrong. And how we can kind of prove this is I can say 90 plus 3 times 8. So if I do 90 plus 3 times 8, I wind up getting 114, which gets me to almost the top of the data. And if I do 90 minus 3 times 8, that's an 8. 90 minus 3 times 8, I wind up getting 66, which gives us the bottom of the data. If I was to use a number other than 8, I would either be spread out too much or spread out not enough, right? So from the mean that I assumed or guessed at, and I can figure out using the top and bottom of the data where everything is. Hopefully this video helped finish up the lesson and helped you with your homework in some way. Best of luck, and probably have a quick quiz after lesson 3, so if you're watching this, you have that hint.